Good day, everybody. Let's get warmed up by talking a little bit more about our exotic looking function here. Now, this is always going to be x raised to n, where n is some integer. Now, we probably have to watch out for 0, because the floor of 0 is 0, but 0 to the 0 is undefined. So we'll go ahead and say a member of z, but n is not equal to 0. There's some notation for that. I can't remember what it is. N is not equal to 0. Don't have to worry about that too much, but again, it wouldn't make much sense. 0 raised to the 0 gets used as an indeterminate form in calculus, but it's not important here. So n could be any integer. So you're going to have except 0, but we're going to have just monomials. It's piecewise going to be equal to just a monomial like x cubed, x to the minus 1, x to the minus 2. Now, just to warm up again here, let's do the ceiling of maybe just the number that we're interested in right here. Minus 15 over 7, the ceiling of minus 15 over 7. Minus 15 over 7, I trapped myself here a little bit, but that's minus 15 over 7, which is the number I chose right here. Now notice that the ceiling here, if this were the ceiling of 15 over 7, the answer would be 3, but it's going to be negative 2. And again, the reasoning is you're going to have minus 2 minus 1, which is negative 3. I'm just writing it in just for the sake of not leaving anything out. Minus 15 over 7 less than or equal to negative 2. Okay? So the ceiling of this number is actually negative 2. And just one more example here that might be a little bit useful as far as just getting started on this problem. What if we had the ceiling of, let's say, minus 3/4? Ceiling minus 3/4. And any other number between minus 1 and 0, that's always going to be equal to 0, which is interesting. And that, of course, that includes any other number, negative number between minus 1 and 0. Okay? So with that in mind, we can actually get a picture of the graph, a rough picture of the graph where, that involves the point where we're trying to find the derivative. Now, let's see. Let's get busy drawing a picture of that. Let's do it maybe like this. Okay, so the xy axis. Now this is just negative 1 right here. We'll call this negative 1. All right, well, as we've just seen, any number in this interval is going to always map to the ceiling of minus 3/4 would map to, since it's going to be x raised to the 0 in this interval is what I'm trying to say. Okay? It's going to be x raised to the 0, so you're always going to get this horizontal line mapping here like this. Okay? Okay, now let's try out negative 2. Okay? Now if you have negative 2, okay, any number in this region is going to have, it will be x to the minus 1, right? Okay, because the ceiling of any number in this region will be x to the minus 1 or 1 over x. Okay? Now, so that would be a number, you'd be taking the reciprocal of a negative number, so you're going to have a number maybe something like this. And y'all, I'm trying to scale it. It would look something along these lines, maybe something like that. Okay, since you're taking the reciprocal, but it's a negative number, so you have this something that's roughly this appearance, right? Okay. Now we're interested though in the number. Our number is between minus 3 and minus 2, right? Well, you know that at minus 2, you would be mapping to 1/4. And let me just write that down. The scaling here is horrible. But if you have minus 2 raised to the minus 2, that's just equal to 1/4, right? Remember, the minus 2 means it'd be minus 2, 1 over minus 2 raised to the 2 power is 1/4, right? And so you see your number would be down right around in here somewhere. And I'm trying to make this legitimate looking. It doesn't look so hot. And your graph would look, I should have made it with more space, but your graph would be approximately something like that. Okay? Now where's our minus 15 over 7? Well, it's about right here. So we're looking for the tangent line about right in there somewhere. And again, apologies, but I think you can see enough to see what I'm talking about. It doesn't have to be perfect, but we are going to have a positive slope that's a fairly flat slope, meaning a slope that's going to be fairly close to 0, it appears, right, folks? Again, minus 15 sevenths is right here, folks. Minus 15 sevenths, I'm sorry. Minus 15 sevenths is about right here because it's a little to the left of negative 2, right? So we're looking for the slope of this tangent line, which looks like it's got to be fairly flat, even though I'm doing my best to do the scaling because this is about 1/4 somewhere in here, okay? So we're looking for the slope of this tangent line. Now here's the part I've already done for you. So f prime, I just wrote that down. It's actually equal to what, 49 over 225 or something. Not that that's important, the value, but that would be the y coordinate of this point right in here, okay? Now, here's your derivative. Remember our good friend, the derivative function, d dx of x to the n. In calculus, you could prove it easy for the positive integers, but it's a little more work for the negative integers, right? But this is like the most famous result in calculus. People on airplanes think they know calculus because they know this, okay? But x to the minus 1, okay? N times, it's well known. You can prove it simply for all the cases. It's not that hard. It's harder for the higher degrees. But anyway, this is a well-known rule. And so that's exactly what I've done right here, folks. Okay, I took the ceiling of minus 24 over 7 is minus 3. Okay? Okay, and so all the rest, it's all here. Okay? Did I get this right? Yeah, it looks good. This 24 over 7, the ceiling. Yes, now that maybe should be. No, everything's looking good, right? Are we in the right spots here? Yep, everything's looking fine. And so we get our result here just by doing our rules, right? This is, I was pointing at the wrong place a while ago, but f prime at minus 17, you get your minus 3 right here, okay, which is the ceiling of this. Blah, blah, blah. There it is, folks, and there's the calculation, okay? You may want to double check it. I'm pretty sure I got it right. So notice that this is a number right around what, maybe 1/5, okay? Approximately 1/5, something like that. It's somewhere like that, but it is a small positive number. It's greater than 0. And remember, that's what we expected right here with our tangent line. Okay, folks? So again, this is slightly confusing what I said up here, but this just gives you the y coordinate of the point. Okay, and now when you take the derivative of this thing, you drag the negative 2 around to the front, then you subtract 1 from negative 2, which is what this says to do, right? And the rest of it's just plain old arithmetic. A little bit of trouble to, a little bit of a pain to simplify this. Not too much, because 7 cubed is 343, right? And 2 times that. A little bit of work to figure out what 15 cubed is. But anyway, the answer to our question is this, okay? 686 over 3375 is the slope of the tangent line to this piecewise function, which is quite interesting. I think the whole thing's very interesting. This part right here about it, how it's constantly equal to 1 right there, you can make up your own problem about that. Like just say, set this whole thing equal to 1, and obviously 1 is an answer, but who would think that all the negative numbers between minus 1 and 0 is also part of the solution set? So that's a problem all by itself. So anyway, that is it, folks, and there's our answer. Thanks for viewing.